Welcome everyone to watch this video. In this video, we will share the deployment practice of campus network solutions based on Asterfusion CXM series products. First, let's take a look at the basic survey information and network planning. Based on the office area and the number of various terminals, we come up with a basic network plan. Adopt span plus leaf network architecture and use Asterfusion controller for unified deployment. This is the network topology planning, and our actual networking will be performed according to this diagram. This is the building plan of the office. After comprehensively considering the walls, conference rooms, corridors, and other information, we deployed the AP in the position as shown in the picture to ensure smooth wireless roaming in the entire office area without losing data packets. We will implement this project according to this step. Next, let's install the controller. First, unzip the controller version file. Then enter the decompressed directory. And use the relevant commands to install it. After the installation is successful, we set the environment variables and replace the default domain name with the domain name app.cloudswitch.ir we have applied for. Then we update the certificate file of the domain name and copy it to the relevant directory of the controller. Next, we can start the controller. After the startup is successful, let's log in through the web. The first login requires a password change. After successful login, we can create our own organization and office space on the controller. After establishing the office space, we import the equipment information into the office space. Now we can see the device information we imported in the warehouse. Next, we will put the equipment on the shelf and power it on. Deploy the AP to the designated location and connect the equipment correctly according to the planned topology. After completing the installation, wiring, and power on work, the device online work can be started. Then we first log into the two spine devices through the serial port and configure temporary internet access information to ensure that the spine devices are online on the control. After completing the setup, we can see that the two spine devices have been successfully online on the controller. Then we set up a temporary DHCP address pool for the spine device on the controller, so that all leaf devices can automatically obtain IP addresses and go online to the controller. Under the script column, there is a default DHCP script. We only need to modify the downstream port to the interface we actually use. Of course, the address pool can also be modified. After modification, we return to the device column and distribute the script to a device. After waiting for a few minutes, the leaf device will automatically come online to the controller. At this point, we start planning the network topology. Select the small to medium-sized network and select the device model for the relevant role. Then you can see the basic topology information. Next, We need to bind the MAC address to each device and set the loopback information. Then interconnect all devices through interfaces. Refer to the plan topology for device connections. Then we drag the AP to the topology page and make relevant settings. All connections here are deployed strictly in accordance with the previously planned topology. After completing the topology configuration, we complete the basic network configuration, including default routing information, MAC information, and IP address information of the uplink interface. At this point, we return to the planning topology page, and we can see that the leaf device is online. We need to turn on the power function of the leaf device interface connected to the AP. Then we can deliver the basic network configuration. After successful delivery, the basic network has been set up. Next, we set up the wide service among them. Leaf 1 and Leaf 2 include AP services, and other leaves are services required by the planned R&D department. VLAN 400 is the AP management service. VLAN 800 is the wireless terminal internet access service under AP. All services have been established. Next, we will deliver these services to the switch device. When the service is successfully delivered, the AP will automatically search for the DHCP server to obtain the address and go online to the controller. We can see the AP on the controller after a few minutes. Next, we need to set up the wireless service, including seed information, authentication mode, password, etc. Then the wireless service configuration is delivered to the AP. After success, the entire network is activated. At this time, we can use a wireless terminal to connect to the Wi-Fi signal to verify whether the network is normal. Next, we set the radio frequency signal configuration. Where channel and TX power was set according to the AP location and separation distance. Adjacent APs should set different channels to reduce signal interference. After all configurations are completed, batch distribution can be carried out. At this point, the deployment of the part network has been completed. Finally, let's take a look at the effect of Asterfusion campus network after it is fully built. This is the overall network map, which includes the network situation of each sub-central. This is the network situation of SC office. This is the online status of wireless terminals in SC office. We can see the device model and access point information. This is the online status of wired terminals, where we can see information such as device access points and overall device traffic. This is the wireless network roaming test data for the entire office area. We can see that no matter in any corner of the office, the terminal devices will not disconnect, and there will be no packet loss, indicating smooth roaming throughout the entire network, satisfied the business needs of users for wireless network roaming. This concludes what I shared today. Thank you all for watching.